All right, good morning, everyone. My name is Eric Sutton, and as Tom mentioned, I also work at Space Weather Trek with Tom and several others across the university campus. Tom gave a pretty good overview of what we do in Trek and how we're organized. I'm going to zoom in on our research enterprise and specifically give a little bit more detail on one of our main research thrusts here, the full physics satellite drag model. So I'll give a little bit of background detail. As most of you probably know, in the last few years, low Earth orbit or LEO has become a very popular destination for a number of commercial applications. I'm showing here on the right hand side here a projection of satellite constellations that are set to pop up over the next couple of years, and you can see the numbers right next to these companies here are in the hundreds, usually hundreds, sometimes thousands of small satellites are going to be going into low Earth orbit. One of the reasons, there's many reasons that's a popular region, but one of the reasons is that it offers a kind of end-of-life contingency for satellites, where you don't have to have a lot of thrust to deorbit your vehicle. So if you're wanting to launch 100 disposable satellites somewhere in space, that's a very desirable place to put them, where you don't necessarily need to have thruster capabilities. So the flip side of that, though, is that because you are interacting heavily with the atmosphere, which is what provides that contingency plan, because of that interaction, you don't always know where your satellites are going to be 1, 2, and 3 days into the future. So this is where our models come in. Our approach has been to take a model of the upper atmosphere and use recent data to calibrate the model or tune the model to give a much better prediction, sort of a real-time correction to a model, if you will. Now this is not necessarily a new way of doing things, but what is new about it is that we adopt some of the most sophisticated full physics models of the atmosphere. Many of them developed over decades and decades right here in Boulder. In fact, I think in the next talk, Tim will give you a little bit of information about one of the models it's running at Ceres and NOAA. And they're also models that we use at the High Altitude Observatory and others. We've had to develop a whole suite of, I call them data assimilation software methods so that we can blend observations with these models, but we're just starting to kind of recognize the advantages of doing it this way. Another thrust we have here is to work with these satellite observations that are coming out of these constellations of satellites, specifically continuous onboard GPS tracking that enables precision orbit determination at a level that has not been done by, say, the DoD or other entities who do tracking and modeling in the upper atmosphere. So here's an example here I'm showing in this plot over to the right here of observations on board a LEO satellite in blue, and also the current operational baseline in red, and along with our model in green. And so you can see all three of these line up pretty well during the quiet period to the left here. But once we get into this geomagnetically disturbed time period, where the solar disturbance has thrust a bunch of particles and higher energy material at the Earth, once this hits the Earth, all bets are off, basically. The red curve essentially just scales up its quiet time behavior, and it doesn't really understand where the energy is coming up in the atmosphere. It doesn't understand where to modify the atmosphere. But with the measurements that we're adding and these new models that we're combining with those measurements, we're able to follow it pretty well. The magnitudes are sometimes off a little bit, but in general, the green curve follows the blue curve in basic terms. So we're really interested in working with satellite providers in towns specifically, and if you have GPS data, we can work with you and translate that into something that might be of value to you and other satellite operators. I'll turn it over to Tim.